Hey, what's up, guys? This is Zheng here. So, today, uh, I want to talk about another LeetCode problem, number 875. Coco eating bananas. Okay, so Coco loves to eat bananas. I'm assuming Coco is like a monkey. Yeah, and there are n piles of bananas. The numbers, the ice pile has like pile ice banana, and the guards have gone and will come back in 8 hours. And so Coco can decide her speed of eating the bananas. Basically, every the speed is k, which means every hour Coco can eat k k bananas, and each hour she can eat k bananas. And if the pile has less than k bananas, she eats all of them instead. And but she won't be eating another pile of bananas, right? And Coco likes to eat slowly, but still wants to finish eating all the bananas before the guards come back. So basically, this asks us to find the minimum K that Cocos can eat all the bananas in 8 hours. Okay, so basically we have three parameters here, right? Or three variables here. The first one is the pile of bananas, right? Second one is H. That's the total hours we have to finish all the piles, all the bananas. And then we need to get the minimum of K, the minimum of K, right? Minimum of K. So, you know, every time when you guys see like about around three variables, like there's a like array of something, and then there's like a second factors, and then it asks you to find the third factors, right? Either minimum or maximum. So then it almost tells you that in this case you need to use a binary search, right? I think that's a very a clear signal that you need to use a binary search in this case. Okay, so for binary search, we need to find the lower bound and upper bound, right? So in this case, what's going to be the lower bound? Basically, the lower bound is going to be the what's the slowest speed possible, right? It's I think it's clear that it's going to be one, right? Regardless of how many bananas, how many piles, or how long the H is, right? The lower bound is always is one because that's the basically eating one banana at 1 hour. That's the slowest speed we can get, right? And then what's the high bound? What's the higher bound, right? The upper bound, sorry. Low and high, right? Then what's the higher bound here? No, since since 1 hour, since like each hour we can only eat one pile, basically, right? Because basically what does it mean is like no regardless how fast we can eat, right? We can only eat one pile per hour, right? So the speed per hour per the highest speed we can I mean we can possibly be using is the maximum around is the maximum among all those piles, right? For example, this one. So the maximum speed we will ever need is 30, right? Because with 30, we can finish each pile within 1 hour. That's the highest we need. You like for 30, 50s, of course, yes, with 50, 40s, we can also finish all the piles in 1 hour, but it's not necessary, right? So the highest we will ever need is the biggest number among all those numbers, right? So Then I think for this binary search problem, we will also have a template, right? Basically, we'll get like middle, right, with a lower bound and upper bound, and then we'll have like a helper functions to help us decide with this middle values, can we satisfy, I mean, can we finish the job? Can we satisfy the conditions in this problem, right? If it can, then we know, okay, we'll find a result in this case, right? So in this case, let's say, so basically our helper function in this for this problem is going to be with this middle speed, can we finish eating all the all the piles within 8 hours, right? If it can, then we know, okay, since we're trying to find the minimum value of this k, right? Then we know, okay, we can try a smaller speed, since at this moment we know it can finish. So then we want to find the minimum. That's why we'll be moving. Then uh we'll be moving to the left half basically, and then we are discarding the right half, right? Basically, we're then assigning this right to the middle. The reason we're sending the middle, not middle minus one, is because it can finish in 8 hours, but this middle might also be our result. We don't know that yet. We only, all we know is that middle can satisfy our condition, and we need to find if this one is the smallest one, right? Otherwise, we just do a left equals to middle plus one, right? So we do a plus one here because we know with the middle speed, we cannot finish eating all the bananas within 8 hours. Then we know middle is not our middle will not be our result. Then we need to try a different one, right? Okay, so with that in mind, let's try to code this thing, right? So like I said, we need like helper functions, right? Let's do a define can finish. Let's just call it finish all the bananas, right? And then we kind of have like a k speed, right? Let's do a k here. And we'll implement this method later on. But first, let's to define a lower. So I prefer use left and right. You can always use the lower and upper. The naming convention doesn't really matter. It's just your own preference. So like I said, the upper bound will be the maximum of the piles, right? And then while left is smaller than right, right? That's basically our normal binary search template. We do a middle equals to what? Left plus um, right minus left divided by 2, right? Then we try that. So for those who still don't know why we're doing this left plus right minus left divided by 2 instead of left plus right, that will prevent the uh, the integer overflow in case the left and right they're both huge numbers. They're almost like reaching the the the, m- the biggest numbers. If we add this like huge number left to the right, it might overflow. That's why we use this left plus right uh, minus left. Use this trick to prevent that from happening. So can finish, right? Can finish, right? So middle. Um, if can finish, right? If basically if it can finish with this speed, right? Then we know, okay, we can try us even smaller, slower speed, right? That's why we discard the right side. Excuse me. And then else, right? Else we do a left equals to middle plus one, right? Like what we discussed before, the reason we do a middle instead of middle minus one is because the middle might be our final answer. We don't know that, right? That's why we still want to keep this middle. If we do a middle minus one here, you know, we'll be missing we might be missing the real answer, right? That's why we will be doing this right here, uh, with close inclusive the middle here, and then in the end we return the right side. Actually, in this case, we can either return left or right because when this while loop is finished, and the left will be equal to right. Okay, and then okay, now let's implement this like finish can finish helper functions. So what we're trying to achieve here is we want to check with the case speed, can we finish eating all the uh, all the bananas within 8 hours, right? So then let's uh, hours needed, right? So let's do hours needed here, okay? And for each pile, right? In piles here, what do we do? We simply do we can use piles divided by k, right? And we can do a ceiling here, right? The reason we're doing a ceiling here is because let's say the k uh let's say the k is 2, speed is 2, and the pile has 3 and the k is 2. So how many hours we need to finish eating this 3 here? 2, right? Because 3 divided by 2 is 1.5, and we need to do a ceiling of this because we need the hour, how many hours we need, right? Okay, pretty straightforward. And then do hours needed, right? And then we do a basically we accumulate all the hours we need, right? And in the end, what do? We return, right? We compares if the hours we needed it's no it's not greater than h, right? If that's the case, we know okay, we know this one is true, we can finish. Otherwise, we return false. All right. Okay, I think that's pretty much it is. I think so. Yeah, that's all about this problem. Okay, let's try to run this. Okay, this one passed. Let's run it. Cool. So, yeah, it passed. Successful. All right. Uh, yeah, pretty straightforward, like binary search problem. I think the only thing is you have to be aware, right? With this kind of problem, right? Like with this like array and a target, and then it asks you to find to to calculate another variable, either if it's minimum and maximum. With this kind of three factors, most likely you'll be using a binary search. And all once you know it's a binary search, all it left is to try to find out the lower bound and upper bound, and then how can you divide, right? How can you divide it into two, and how can you move to the left half or the right half? Okay, cool, guys. I think that's it for this problem. Yeah, thank you so much for watching the video, and I'll be seeing you guys soon. Bye bye.